Welcome to day 2 of the virtual science class for 2021. Today we're going to learn a little bit about the quantities that are used to measure in the metric system. You should have about page 3, 4, and 5 of your notes and be ready to go. Yesterday we learned how to convert units in the metric system, so we already learned about some different base units. When we think about distance or length, it's the distance between 2 points. The base unit we use, as we said yesterday, is the meter. Typically we use a meter stick or a ruler to find the distance between 2 points. Matter is the amount of mass is the amount of matter in an object. In the metric system, our base unit is grams. Typically we use a balance beam. The reason why we use a balance beam is because we're looking for the amount of matter in an object. So whatever we put on the pan of the balance beam is balanced by the weights on this side. This will never change. We could take it to the moon, we could take it anywhere on Earth, and the weights are going to balance what's in here because the amount of matter in the weights and the amount of matter we put on the pan is not going to change. When we think about volume, volume is the amount of space that an object takes up. And if it's liquid volume, it could be liters, which is the base unit, or it could be in cubic meters. If it's liquid volume, we're going to use a graduated cylinder. When we use a graduated cylinder, if the liquid came up here to where I'm drawing this red line, we would look at it. This is our eye over here. We would look at it straight on. We don't want to look from an angle up or from an angle down. If we're finding the length, width, and height of something, so that we're going to find meters squared, because we would multiply the length of them in meters times the width in meters, that would be meters times meters, times the height, that would be meters squared, we would use a metric ruler. Okay. Weight is the measurement in the amount of force on an object, the force of gravity, pulling it down. In the standard or imperial system, we use pounds when we talk about our weight. In the metric system, we use a unit called the Newton, which was named after Sir Isaac Newton and his laws. Typically, we use a scale. So like these spring scales here, they're going to measure how much gravity pulls on whatever we hang on the hook and how much gravity pulls it to the earth. Temperature is measured in either degrees Celsius, which is what most people use around the earth, around the world, or degrees Kelvin. And we're going to talk more about degrees Kelvin later in the year. Degrees Kelvin would be used by people who measure very, very cold temperatures. We use a thermometer. It could be a thermometer like this. It has liquid in it. When it warms up, the liquid expands and goes up the tube. Or it could be a digital thermometer. Okay. Now, I just want to take a review of the difference between mass and weight. So weight was the measure of the force of gravity on a person. You know, up on the moon, there's less gravity. There's 1/6 the gravity on the Earth as there is on the moon as there is on the Earth. So if we had a scale, and we put a person on that scale, on Earth, gravity would pull them down more and stretch out the spring more than it would on the moon, where there's less gravity. So when we say our weight is the measure of the force of gravity, it's how much it's pulling down on the scale. This is different than mass. We take this same person and put him on a scale, or she on a scale, and we find something that balances them. They'll balance wherever. The amount of matter in this diamond-shaped object is not going to change, and the amount of matter in this person is not going to change. So it wouldn't matter if we measured them on Earth or on the moon. Okay, they would still balance. And this is why we use a balance beam in science, and scientists use balances because it's something that doesn't change. Okay, the amount of mass in the person and the amount of mass in this object won't change. So on our balance beam, these would be the weights that we slide around. So whatever we're trying to find the mass of, we move the weights around until they balance. Okay, and again, gravity measures how much weight pulls you down. So on the Earth, where there's more gravity, you would be pulled down harder than if you were on the moon. Density is an important property of matter. So today we're going to learn a little bit about how to calculate density. And we've been talking about mass, which is the amount of matter in an object, and volume and the amount of space it takes up. Density is the amount of matter or mass in a certain amount of space. So if there's a lot of matter in a small amount of space, we would say it's very dense. So something like a steel block or a concrete block, it takes up a small amount of space, but there's a lot of matter in it. So we would say that big chunk of steel or concrete would be very dense. Now imagine though if we had something that was the same size, it took up the same space, and it had the same volume. It didn't have very much mass. Maybe it's feathers or some foam. We have a small mass divided by the same volume, and we would say it's not very dense. Now, we're going to use this triangle all year long. Okay? And what we're going to find out is that we can put any formula like this into the triangle. And we're going to put the formula in a triangle so the divided part, the mass divided by volume, is top and on bottom. This bar in the middle is going to be like a fraction bar. Okay? So whatever's on the top is going to be divided by what's on the bottom. So if it's mass on top and volume on the bottom, we're going to divide mass by the volume. So if the two numbers that you know fill the triangle so that one is on top and one is on the bottom, then we divide. If the numbers that we have in our problem are next to each other, then we know, just like in math, the numbers are next to each other, we multiply. So if we knew the density and we knew the volume, then the numbers would be together on the bottom of the triangle, and we would multiply. Calculating density when you have two or three parts of the formula. First, whenever you read a word problem or any problem, you've got to decide what the problem is asking. You can't answer a question if you don't know what the question is. Then you're going to fill in the parts of the triangle that you know. You're going to use this triangle to do the math so that you don't make mistakes. Now let's look at an example problem. It says a sample of fluid has a volume of 30 milliliters. So this is an important keyword. And it says it has a mass of 90 grams. And it says, what is the density of the fluid? When you read what is the density, that's the first thing. That's the side what the question is asking. They're asking you to find the density. So this is a density question. And we're going to put a question mark where the D is in the triangle. The next thing that we see in the problem is this 30 milliliters. 30 milliliters is volume. So we're going to put the 30 milliliters where the V is in the triangle. And then we read it at a mass of 90 grams. 90 grams is mass. So we're going to put 90 grams where the M is in the triangle. The numbers are on the top and bottom, so we know we need to divide. So here's our problem right here. 90 grams divided by 30 milligrams. Okay, so we're going to take 90 divided by 30, we're going to get 3. And our unit is going to be grams divided by milliliters. Now, units work just like variables in math. If you had 90x divided by 30y, that would equal 3. And you can't cancel these because they're different. So we would have 3x divided by y would be our answer. Well, that's just the same thing as the grams divided by milliliters. Another example is like this problem. It says, calculate the mass of a wooden block that has a volume of 50 centimeters cubed and it has a density of 6 grams per centimeters cubed. Well, the first thing we do is find out what is the question asking. Well, they're telling us what they want us to do. They say calculate the mass. The first thing we want to do is get the formula in the triangle. So we're going to say density, and then the divided by part goes on top, mass divided by volume. When it says calculate the mass, it's asking us to find mass. So we're going to put a question mark where the mass is in the triangle. The next number we came to was the volume of 50 centimeters cubed. So 50 centimeters cubed is our volume. So we're going to put 50 centimeters cubed where the V is in the triangle. Then we read a density of 6 grams per centimeter cubed. 6 grams per centimeter cubed is density, so we're going to put the 6 grams per centimeter cubed in the triangle. Now the numbers are down here next to each other on in the triangle, so we know that we need to multiply. So there's our problem right there, just like what's on the bottom of the triangle. 6 grams per centimeter cubed times 50 centimeters cubed. Variables, the units work just like variables, so we have centimeters cubed on the bottom and centimeters cubed on the bottom and on the top, and they're going to cancel out. So we have 6 grams times 50, and that equals 300 grams, which makes sense because they said find mass, and we already know that the base unit for mass is grams. Another problem might be like this one. It says sample of liquid has a mass of 6 grams, has a density of 2 grams per milliliter. What is the volume? Okay, so the first thing we think to ourselves is, what is the volume? What is the volume? That's the question. That's what they want us to find out. So this is a volume question. Okay, first thing we're going to do is get the formula in a triangle. They're asking us to find volume, so we're going to put a question mark where the V is in the triangle. We read mass of 6 grams. So 6 grams is mass. So we're going to put the 6 grams where the mass is in the triangle. And we said the problem said a density of 2 grams per milliliter. So 2 grams per milliliter is density. We're going to put the 2 grams per milliliter in the triangle. And here's our problem right here. We have 6 grams divided by, here's the bar, 2 grams per milliliter. So the numbers are on the top and the bottom, and we know we need to divide. And here's our problem. 6 grams divided by 2 grams per milliliter. We're going to cancel off the grams. It makes sense that the unit for volume would be milliliters. Okay. So it equals 3. 6 divided by 2 is 3. And the unit that's left, because we canceled off the grams, is milliliters.